we have seen from this graph that as measured as number of people who die per unit of electricity production, all forms of electricity kill people, but actually nuclear is one of the safest. It's comparable to wind and solar and drastically hundreds of times safer than oil, coal, or even biomass, gas or hydropower. And this is despite Chernobyl, which is the only case where nuclear power has killed people. Fukushima and 3 Mile Island did not. We had 3 accidents, and between them, depends exactly how you count how many people have killed. The number of direct deaths is lower. Maybe there's a large number of people who were killed by small radiation doses, as we talked about, but even factoring that in, it's pretty safe so far. But people would argue, sure, it's been safe so far, but there are lots of things which are safe most of the time, like not wearing a seatbelt in your car. Most of the time you're going to be fine, but occasionally it can kill you. So it could be that, so far we've not had a really bad nuclear disaster. Chernobyl was pretty bad, but could it get much worse than this? What is the worst case scenario? Could there be a small probability, really catastrophic device that would change these figures around and make nuclear very dangerous? Now we know that nuclear reactors can't explode as atomic bombs. Uranium is not enriched anything like enough. So probably the worst case scenario for a nuclear reactor is the radiation getting out. There's a lot of radiation in the core of these things. Now the estimates are that about 5% of the core radioactivity at Chernobyl escaped. And that involved a runaway reaction, multiple explosions and minimal containment. The other disasters, it's been much less than 5%, only tiny amounts. So one question is, could you actually get like 50% of the radioactivity out? And it's hard to rule this out, but it's very hard to see how it could happen. Given that Chernobyl with multiple explosions, you only lost 5%, people have talked about maybe terrorists crash an aircraft into these things, but most of the radioactive material is heavy chunks of encapsulated metal. It's not easy to turn that into a dust and blow it into the air or turn it into a gas that flies around. Most of it's going to stay pretty much put. Even if it is blown up by an explosion, it might get scattered a few hundred meters, but then will just fall to the ground again. So most of the radioactive material is heavy metals which don't spread easily, and modern reactors have huge concrete containment vessels that are actually very strong, so general design is that planes could crash into them probably without doing too much damage. It might cause a meltdown, as at Fukushima, but that doesn't release very much radiation. We know what that produces. But we know that radiation can sometimes escape. Could we end up with large parts of the world that are uninhabitable for thousands of years because of radiation contamination? Well, let's look at what happened with Chernobyl and Fukushima. So here is a radiation map from September 2021, so a long time after the disaster, showing the radiation dose you would get in various locations around the Chernobyl reactor. They didn't measure it right in close because it's a no-fly zone. These measurements were made from an aircraft. But these are the doses in microsieverts per hour. So 1 microsievert per hour, which is the slightly pink colour, is corresponding to 8 millisieverts per year, which is about the same as a natural radiation dose in Denver, Colorado. And we've seen Denver has a lower cancer rate than most parts of the US. So you can see that most of these areas are quite low radiation at this point, which is 30-40 years after the disaster. There are regions with higher, the red and orange. Even then, though, the radiation is not very high. It might give you a few % chance of dying of cancer if you spend a lifetime in there. Maybe, if the linear no threshold model is correct, but maybe not, if it isn't. But that's much smaller than many other things that will kill you from cancer. And it's quite localized areas. There are plumes where presumably the winds immediately after the disaster blew some of the radioactive isotopes, and in particular patches, some of which interestingly are out of the exclusion zones. And there's plumes going up to the north, which related to Russia, where they were not able to make the flight measurements. So, yes, there are regions which are dangerous, but they're not that dangerous, and the actual contaminated regions are pretty small. How about Fukushima? That's a much more recent disaster, only a little bit over 10 years ago. So this is a map from a few years ago showing the radiation. You can see once again there's a plume heading to the northeast from the actual location of the reactor where most of the radioactive gases are blown, and then it turns down here, probably from a change in the wind that blew the cloud down this direction, and there are a few bits in other directions as well. here are the data, again in microsieverts per hour. However, since this was made, the doses have dropped. In the most intense regions, really close in here, the worst hit regions have doses of about 40 millisieverts per year. So that's about 10 times the natural background radiation in most parts of the world, and maybe 4 times the natural background radiation in places like Colorado, but there are plenty of places in the world with natural doses higher than this. But by the time you're 1 kilometre away, doses drop to about 5 millisieverts per year, again more than the average dose in Australia, but less than in many parts of the world. And in 10 kilometres away, doses are less than 1 millisievert per year, so less than even Australia's natural dose. So there is a region where it's high, but even in the high regions, it's going to be maybe, if you believe the linear no threshold model, a few % chance of dying from cancer, but many other things from cancer will kill you much more rapidly. For example, if you let people move back into that region but ban them from smoking, because smoking cigarettes gives you a much higher risk of cancer than this 40 millisieverts per year, then you'd have a lower death rate there than a region outside where people were allowed to smoke. So I'm not sure that there's a clear story here. Yes, there is a contaminated region. How deadly is the contaminated region? Not very deadly, and it's pretty small, but there is a real risk. But there are other risks we take in our life which are much worse. So what do you make of that? It's not a clear story. Now, one possible problem is that radioactive elements can be concentrated biological processes. For example, in southern Germany, which we saw got a slightly higher dose from Chernobyl, wild boars, these wild pigs, are actually quite radioactive. And no one knew why until recent research showed that they were eating a particular underground fungus that turns out to concentrate radioactive cesium. It was thought this came from Chernobyl, but actually it was turned out from the exact isotope ratios it doesn't. It was actually from nuclear testing well before Chernobyl, which was spread all around the world. And it just so happens that this particular fungus combined with this particular pig is concentrating it to make them a bit more radioactive. So hunters are actually not allowed to eat the meat from wild boars, which is causing problems because they're not being hunted. There are more and more of them around doing damage. Currently, there's a big scare about the releases of radioactive water from Fukushima. So Fukushima, the cooling system failed, and so to keep that residual 3% of heat in the reactor from causing it to melt down, huge amounts of seawater were pumped through the reactor to keep it cool. And this water became somewhat radioactive and has been stored in tanks on site. And they've got more and more and more tanks that are filled up with this water until there's just no more room to put it all. So they've got to do something with it. And this is causing, at the time of filming this, a huge furore. Here's a newspaper story from the BBC about in China. Rocks thrown at schools, threats of a boycott and hundreds of hostile phone calls. These are just some ways Chinese people have shown their displeasure with Japan in recent weeks because of their release of treated wastewater. So, for example, Japanese seafood has been banned across large parts of the world. Is this sensible? Well, the water has been treated to remove all the metals like cesium that are radioactive. So, is it still radioactive? Well, it is a little bit radioactive because it's got some tritium in it. The radioactivity causes some of the hydrogen to turn from hydrogen with one proton to hydrogen with one proton plus two neutrons, i.e. tritium, which is a radioactive isotope of hydrogen. And this cannot be removed chemically because it's chemically identical to hydrogen. Any chemical reaction that will get tritium will also get hydrogen. To remove it, you'd need, I don't know, to have some sort of similar process to the one used for making heavy water or to concentrate uranium, which is just not feasible for the thousands and thousands of tons of water there. So it's being released still with tritium. So they're releasing radioactive water. Well, yes and no. The radioactive water is actually less radioactive than seawater normally is. Normal seawater has potassium-40 and a few other elements in it, and is actually about 4 times more radioactive than what they're releasing. So actually by releasing the water, they're actually reducing the radioactivity of the sea. Of course, that doesn't get covered in the media. But maybe radioactive water with tritium is more dangerous than radioactive water with potassium-40 because maybe the tritium is concentrated in particular fish. Fish drink water, maybe the tritium builds up in them. Well, not really, because, as we've said, tritium cannot be chemically separated from hydrogen. So the concentration of tritium in fish is going to be the same as the concentration anywhere else in the water around them, i.e. very, very low. So it's not going to make them more radioactive, whereas other things like heavy metals can be concentrated. So in fact, tritium is the safest radiation, and indeed measurements of the radioactivity in seafood show that it's no higher than normal, and of course normal seafood is to some extent radioactive wherever it comes from in the world. So in fact, the water being released is less radioactive than normal seawater. It'll be diluted by factors of billions because the Pacific Ocean is big. It's being pumped kilometres out before it's released. It's pre-mixed before it even goes out. Tritium is less dangerous than other radioactive elements, and testing shows no increase in radioactivity of seafood. So really, scientifically, this is safe. It is not having any risk whatsoever, but that doesn't stop people panicking, freaking out, diplomatic protests, seafood bans. So many Japanese people fight against it, either because they don't trust the government, they don't trust the science, or simply because they know that other countries will freak out and ban their seafood and destroy their economy, even though there's no risk.